Okay, so get this. Have you ever heard that expression, freezing time?
Yeah, I think everyone has at some point, right?
Yeah, like it's always in those sci-fi movies, right?
Yeah.
Well, this article we're looking at today, freezing time, the revolutionary tech behind reliable quantum computing,
Okay.
from Chalmers University of Technology, talks about scientists actually getting close to doing that, at least when it comes to these super powerful computers, quantum computers.
Yeah, it's not exactly like stopping time,
Right.
like we normally think about it.
Yeah.
But it's more about controlling these super fragile quantum states, you know? It's like,
Yeah.
imagine a world where just looking at something changes it.
Whoa.
And that's the kind of crazy, delicate dance we're talking about with quantum computers.
Okay, so help me out here. I know that quantum computers are supposed to be, like, way faster
Right.
and more powerful than, like, a normal computer.
Yeah.
But why? Like, what is the thing that makes them so special?
It all comes down to qubits.
Yeah.
So regular computers use bits, which can be either a 0 or a 1.
Okay.
But get this, quantum computers, they use qubits.
Right.
And these qubits can be both 0 and 1 at the same time.
Whoa.
Yeah, it's like they have this superpower called superposition.
So it's like they're in multiple realities at the same time.
Exactly.
That's crazy. And is that how they do these crazy calculations that would take normal computers, like, forever?
Exactly. That's what gives them the potential to, like revolutionize everything from medicine to energy to AI.
Oh, wow.
So think about it.
Yeah.
Faster drug discovery, more accurate climate models,
Okay.
even breakthroughs in material science, all things that could have a huge impact on our lives.
Okay, that's starting to make sense.
Yeah.
But this article also mentions that these qubits are super sensitive.
Right?
So what's the deal with that?
It's like, imagine you're trying to balance like a spinning coin on its edge.
Okay.
The slightest little nudge.
Yeah.
And it topples over.
Right.
Well, qubits are kind of like that. So any interference from heat, light, even the tiniest vibration can knock them out of their delicate state and cause errors in calculations.
So it's like they need a super zen, perfectly calm environment to work their magic.
Pretty much.
And that's where this new refrigeration technology comes in, right?
Yeah.
It's like creating a super chilled sanctuary for these very fussy qubits.
You got it. So the colder they are, the less likely they are to be disturbed. Current methods use something called dilution refrigerators,
Right.
which can get them pretty close to absolute 0.
Wow.
About 50 millikelvin above it, to be precise.
Whoa, that's unimaginably cold.
Yeah.
But apparently it's not cold enough for these, quantum divas.
Not quite.
Oh.
That's where this new quantum refrigerator comes in.
Oh.
Researchers at Chalmers and the University of Maryland have managed to cool qubits down to a record 22 millikelvin.
Okay, I get that that's colder, but how big of a deal is that really? Does a few millikelvin make that much of a difference?
It's a huge difference.
Right.
Remember that 99.97% ground state probability the article mentioned?
Vaguely.
Okay, so that's the sweet spot where qubits are most likely to be in their lowest energy state, ready to do their thing.
Gotcha.
And this new cooling method gets us closer to that ideal state than ever before.
So it's not just about being cold, it's about being in the right state to do these complex calculations.
Exactly.
Okay, but how does this quantum refrigerator even work? I mean, it sounds like something straight out of Star Trek.
Well, it's actually pretty elegant.
All right.
Imagine like a tiny little air conditioner for qubits.
Okay.
But instead of using like Freon,
Right.
it uses the strangeness of quantum mechanics to move heat around.
Okay.
It involves superconducting circuits and the interaction of 3 qubits, including the one we want to cool.
So are these other qubits like tiny quantum ice packs?
Kind of, yeah. One of them absorbs energy from a warmer area, kind of like soaking up the heat.
Right.
The other one releases that heat into a colder area, effectively pumping the heat away from the target qubit.
Okay.
And get this, it's self-sustaining, powered by the heat from the environment.
So it's like a perpetual motion machine, but for cooling.
Kind of, yeah.
That's incredible. It seems like this technology has the potential to really unlock the power of quantum computing.
Yeah.
But we've only scratched the surface here, right?
Oh, yeah, absolutely.
There's so much more to explore.
Yeah, definitely.
I can't wait to dive deeper into that.
Mm-hmm.
But first, I think I need a moment to process all this quantum coolness.
Yeah, for sure. Me too.
Hmm.
So, before we
Yeah.
went on that little mental break there. We were
Yeah.
talking about how this new quantum refrigerator could really
Yeah.
shake things up in fields like medicine and energy.
Right.
But with any powerful technology,
Yeah.
there are always those what-if questions.
Right.
Like, what could go wrong?
Yeah, I was just thinking about that. It's all well and good to talk about personalized medicine and
Right.
clean energy and all this stuff. But what about the potential downsides?
Yeah.
Like I've heard some people worried about what quantum computers could mean for things like cybersecurity.
Oh, yeah, that's a valid concern.
Right.
I mean, quantum computers are so powerful
Yeah.
that they could crack the codes that we use to protect all of our sensitive data,
Wow.
like online banking, government secrets,
Okay.
you name it.
So it's not just that our computers will feel slow compared to these quantum computers. It's that our whole digital world could be vulnerable.
Yeah.
That's a little unsettling.
It's definitely a challenge, but the good news is
Yeah.
researchers are already working really hard to develop new types of encryption,
Okay.
quantum-resistant encryption,
Right.
to stay ahead of the game.
So it's like an arms race then,
Yeah.
trying to stay one step ahead of the quantum code breakers.
Yeah, you could say that.
Hmm.
But it's a race we need to win
Yeah.
to make sure that quantum computing is used for good and not for malicious purposes.
Right, right. And I've also heard people express concerns about quantum computing leading to job losses. Is that something we should be worried about?
It's a real possibility.
Yeah.
I mean, we've already seen how automation can disrupt industries.
Right.
And quantum computing could accelerate that trend even more.
Yeah.
So tasks that currently require human intelligence, like analyzing data or making complex decisions,
Okay.
could become automated.
So it's not just factory workers or truck drivers. It could be people in finance, law, even medicine.
Potentially, yeah.
Wow.
But, it's not all doom and gloom.
Okay.
New industries will emerge around quantum computing itself.
Okay.
Like, think about it. We'll need quantum engineers, programmers, technicians
Right.
to build and maintain these systems.
So it's not about feeling the future, but about adapting and evolving with the technology, making sure that people have the skills and training to thrive in this quantum-powered world.
Exactly. And it's about having these open and honest conversations about the potential impacts of quantum computing,
Yeah.
both positive and negative.
Right.
And we need to make sure that this technology benefits all of humanity,
Right.
not just a select few.
So it sounds like we need to be proactive, not reactive,
Yes.
and to have guidelines and regulations in place from the get-go.
Absolutely. We need to think about things like data privacy,
Right.
algorithmic bias,
Yeah.
and access to quantum technology.
Okay.
We need to make sure it's used ethically and responsibly.
It's like we're standing on the edge of a new frontier,
Yeah,
and we need to chart this course very carefully.
right.
We have this incredible power at our fingertips, and it's up to us to use it wisely.
I couldn't have said it better myself.
Yeah.
And speaking of charting the course,
Yeah.
let's shift gears for a second and talk about what this all means for the average person,
Yeah, that's a good point.
Like, how will quantum computing actually impact their lives?
Yeah, we've been talking about all these big kind of abstract concepts, but how will this technology actually touch people's lives in a more tangible way?
So let's start with healthcare.
Okay.
Imagine a world where your doctor can use a quantum computer to design a personalized treatment plan just for you,
Okay.
based on your own unique genetic makeup.
Okay, now that's something I can definitely get behind.
Right.
No more one-size-fits-all medicine. That would be incredible. What else?
Well, think about energy.
Okay.
Quantum computers could help us develop new types of solar cells that are way more efficient
Right.
than anything we have today.
Wow.
So imagine a future where clean energy is abundant and affordable for everyone.
Wow. That would be game-changing, especially with climate change being such a pressing issue.
Right.
So it's about improving our lives on multiple fronts.
Yeah.
Health, energy, and beyond.
Exactly. And these are just a few examples, As quantum computing continues to evolve,
Yeah.
the possibilities are truly endless.
Yeah.
I mean, we're talking about potentially solving some of the biggest challenges facing humanity.
It's almost like stepping into a new era. A quantum era where the impossible becomes possible.
Yeah.
It's a little daunting, but also incredibly exciting.
It is indeed. And it's important to remember that this is not just some distant future scenario.
Right.
These advancements are happening now,
Yeah.
and they're accelerating rapidly.
So we need to be prepared for this quantum future,
Yes.
to understand it, to engage with it, and to shape it in a way that benefits all of us.
Absolutely. The quantum era is upon us, and it's up to us to make the most of it.
Okay, so we've talked about the potential benefits, the potential risks,
Yeah.
how quantum computing could impact our daily lives.
Right.
But there's another layer to this that we haven't really explored yet,
Yeah.
the philosophical implications.
Yeah, this is where things get really interesting. We've touched on this idea of quantum time
Right.
and how quantum computers can explore multiple possibilities simultaneously.
Yeah.
But what does that actually mean for our understanding of reality, of free will,
Whoa,
of the very nature of existence itself?
those are some deep questions.
Yeah.
And I have a feeling we're only scratching the surface here, but I'm definitely ready to dive in and see where this conversation takes us.
Me too.
Okay, so we've been talking about these quantum computers and like how they work and all this stuff.
Yeah.
But now I'm really curious about something you mentioned earlier, this idea of quantum time.
Right.
It sounds like something straight out of like a science fiction movie.
It does, doesn't it?
Right.
But it's actually a real concept that physicists are dealing with.
Yeah.
See, in the quantum world, things aren't as simple as, clear cut. It's not just about cause and effect,
Yeah.
like we're used to in our everyday lives.
So walk me through this. How is time different in this quantum realm?
Okay, so think about it this way. In our normal world,
Yeah.
time moves forward
Right.
in a straight line
Yeah.
from past to present to future.
Right, right.
But in the quantum world, things can exist in multiple states at the same time.
Whoa.
So it's like having all the different possibilities of a story
Yeah.
unfolding all at the same time.
So it's like those choose your own adventure books where you get to decide what happens next.
It's similar to that, but even weirder.
Yeah.
It's not just that multiple possibilities exist.
Yeah.
It's that they all exist at the same time.
Whoa.
And it's not until we make a measurement
Okay.
or an observation
Yeah.
that one of those possibilities becomes our reality.
Wow. Okay. So does that mean that our future is like already predetermined?
Yeah.
Or do we actually have the power to choose our own path?
Well, that's the million-dollar question, isn't it? It kind of gets to that age-old debate about free will versus determinism.
Right.
And quantum mechanics doesn't really give us a definitive answer,
Yeah.
but it definitely adds a new dimension to the conversation.
So maybe it's not about choosing one specific future, but it's about navigating through all of these possibilities.
Yeah, that's a really good way to think about it.
Okay.
And remember, quantum computers can tap into this weirdness of quantum time.
Right.
They can explore multiple paths at once. And that's one of the things that makes them so powerful.
So it's like they have a shortcut through time and they can see what might happen and then choose the best course of action.
Yeah, in a way, yes.
Whoa.
They can process information in ways that kind of defy our normal understanding of time.
Yeah.
And this ability to explore multiple possibilities simultaneously is what gives them the potential to solve problems that are just impossible for classical computers to tackle.
It's incredible and a little bit frightening to think about.
Yeah.
It's like we're peering into the very fabric of reality
Mm-hmm.
and realizing that it's not as fixed and predictable as we always thought.
Exactly. And it makes you wonder about the role of consciousness in all of this.
Oh, wow.
Like some physicists think that consciousness might actually play a role in collapsing the wave function.
Okay.
Like in choosing which possibility becomes our reality.
Now we're really going down the rabbit hole here, but that's what makes this so fascinating.
I know, right?
We're talking about quantum computers, but we're also talking about the nature of reality, of consciousness,
Right.
of what it means to actually exist in this universe.
It's all interconnected, and I think that's one of the most important takeaways from this whole discussion.
Yeah.
Quantum computing isn't just about building faster computers, it's about expanding our understanding of the universe and our place in it.
It's like this technology is forcing us to ask these big questions that philosophers have been pondering for centuries.
Right.
It's both humbling and inspiring at the same time.
It is. And, as we continue to explore this quantum realm,
Yeah.
I think we're going to uncover even more mind-blowing discoveries that will, challenge our assumptions and reshape our understanding of everything.
It's like we're on the cusp of a new era of scientific exploration, like a quantum era where anything is possible.
Precisely. And who knows what wonders await us on this journey.
Right.
Maybe we'll even find answers to some of those age-old philosophical questions.
Well, on that note of cosmic mystery and endless possibility, I think it's time for us to wrap up this deep dive.
Yeah.
It's been an incredible journey through the world of quantum computing, and I feel like we've only just scratched the surface.
It has been a pleasure exploring these ideas with you.
Likewise.
And to all of you listening out there, we encourage you to keep those minds open and never stop questioning and exploring and just marveling at the mysteries of the universe.
And who knows, maybe one day you'll be the one making the next groundbreaking discovery in quantum computing.
That's right.
Until next time, keep those qubits cool and those imaginations firing.
Yeah.
Thanks for joining us on The Deep Dive.